Hello guys, welcome back to my video. Today I'm going to teach you more about UMO calculus. I introduced that at the start of my first video. I'm going to go more into it. And today in this video, I'm going to teach you something new. It's called collectrons. I promise it's a chance this might actually exist and a chance it might not. Collectrons. So, imagine electron. Everyone knows what an electron is. Let's just write it as E with a bar above it. Well, we all know every single electron is always negative. It's always negative. There's no such thing as a positive electron except in antimatter. Okay, so back to the topic. Remember I told you what a column is in my first video? A column is where you hold answers. Well, a collection would be equivalent to a negative electron times a positive electron times a negative electron times a positive electron times a negative electron times a positive electron times a negative electron, and forever. And first you might think, what even is a positive electron? Doesn't that not exist? Well, it actually does exist, and it's not what you think. So imagine this. You have a negative charged electron, two negative charged ones. And as you know, in standard mathematics, a negative times a negative is a positive. Well, we can't multiply the electron itself, but we could have multiplied the charges. So doing math, we have negative charge times negative charge equals positive charge. Negative times negative equals positive. And over time, it'll form its own shell called the Qton. I kind of forgot the name. So that's how you make a positive electron. This is 100% real. And the positive electron, it'll be also guarded by a barrier. It's an imaginary one. Imaginary. 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 Okay. So enough yapping about that. Let's go to what a collectron actually is. Since a collectron is a positive electron times a negative electron times a positive electron times a positive electron, and so on. The amount of electrical charge in a collectron will be so great. It's like the most electric thing ever. So basically what I'm saying is, if the collectron is greater than 1, then the energy will be so great it just turns into a black hole. So the collectron, it always has to be between the limit of 1. Anything above it. Sorry guys, I had to end the video there. But guys, then you know, there's a formula to calculate the amount of collectrons in anything. And the formula is Q squared divided by R. R is the radius. Equals radius. And Q is the amount of electrical charge in coulombs. No, I don't know how to say the name, but it's not these things I introduced in my first video called coulombs. It's coulombs. Search it up later, guys. This is how to find the amount of collectrons in anything, right here. Hey guys again! Right now we're about to learn a new topic called collectri. Remember, collectron was kind of crazy. It was the most electric thing ever. Well, collectri, it's like the most outward thing ever. Like, it pushes the most. Kind of like a white hole. Like, nothing can enter a white hole because it all pushes out. A collectri is Same thing. So the volume for the how to find the amount of electron or force. This is the formula for it, where this little thingamajiggy is the amount of outward space. Outward space. So electron equals outward space times volume. So for example, I don't think you should try standing too close to a electron particle or else you'll just bend around it. Because the force is so huge. Wow. Wow. Actually just wow. I promise you this actually does exist. Without it we'll just collapse into a straight line. Because without the next topic, and now the next topic is super important. It's called Kenton. And without it, we pretty much couldn't be able to do a lot of things. Like, for example, a Kenton is the reason most things are straight today. Like, without a Kenton, you'll be flipping around 360 degrees every single second. A Kenton keeps everything straight and in balance. Without a Kenton, you basically, everything will be a wavy line and not straight. I just don't have proof a Kenton exists, but I know it exists. And the formula for Kenton is C4 divided by G. I'm pretty sure you know what all this means. G is just gravity in newtons, and C is just the speed of light. This is a Kenton. Basically, it keeps everything straight and in balance. But without it, I'm pretty sure everything will be wavy and all this. And everything you see, probably even your cat, will probably be all wavy without it. Thanks to everything. Thanks to Kenton, we are actually straight and actually can walk without being wavy. But good thing. Actually, here's a tip. Don't stand too close to a Kenton or else you'll be so straight that you'll be pulled into a straight line. And this is the formula for Kenton. Now, time to show you a stability factor. Stability factor equals electron divided by Kenton plus electron. Now, since you mastered all of these, electron is the extreme electrical force. Kenton is the straight force, the balance, and electron is the outward force. This is the stability factor. Here's one more thing about electron you need to know. If you see a electron, it'll most likely be in a form of this, where the center is the most brightest. Around it is some random liquid because it's the result of molten plasma. Outside is a glowing purple light, and outside is the core. I mean, no, not the core, the crust. And then outside is the insane electric field. But here's a tip. Don't stand too close to a electron. Let's say this is you. Since a electron, their magnetic field is so strong, it will instantly burn all of your atoms apart and turn you into a cloud of plasma dust. And finally, guys, as you see, this is an approximation of how a electron might look. As you see, the center is supposed to be the most brightest part ever, but it's so bright the camera can't even capture it. And outside, you see there's like a little purple light. That's what I was talking about, as the radiation. And then outside is the electric field, which is actually the most dangerous part. This is how a electron looks. I'm gonna teach you more about it, guys, next video. See you later. Bye, guys.